amazing game development going on right here. This is crazy levels of pushing the boundaries. Really pushing the boundaries of what can be done with code. Welcome to the stream. We're going to be drawing a little bit, sketching a little bit, generally developing a very simple game over the course of a couple of live streams. Good segue, Steven Zombies. The game that we're going to be making today is... Like to maybe a wall or something. Which is anyway, there's good things to do. Yeah, they make walls, love, they make walls now. They can cause other cubes to also exist on the map. They can cause other cubes to roll in a direction, in a specific direction. Anytime we cause a cube to roll, either to roll left, or up, or right, or down. This is difficult to draw, isn't it? I might as well just try and show it actually, you know what? What mode is the mic on? That's a good point. Is the mode on the... Oh! Hang on. How's that? Is that better? The first live stream on YouTube and this happens. This is the game, right? This is the original Owl's Breeze. Yeah, there you go. Alright, everyone turn down your volumes after turning it up so far, just trying to hear me. Jeez Louise. Alright, Owl's Breeze. You can see that if you push on some buttons, they move another cube in a certain direction, right? So that's another mechanic. We're going to be using Unity. Unity 3D is our game engine of choice. It's the one I've got the most experience with. And we're going to be coding in Visual Studio, because it has a nice dark theme. We're going to just try and get this cube rolling around. That's probably going to be the start of today's, and we're going to gradually build things up from there. So we should be able to see this just slide around really easily. Restart our simulation. Whoa, and it shoots forward. Alright, so the reason for that is because every single frame, that thing is jumping forwards, right? If you think about it, translate by 1 meter, like every frame. If you're running at 60 frames a second, that's 60 meters every second. That's crazy. Crazy big. So what you do is you temper it by the rate at which this update gets called, right? And that is time.delta time. It's a very small number. It tempers it, makes it far smaller. There you go. So we shouldn't see so massive of a change. We should see something more like this. Yeah? We're facing in the wrong direction with our camera, actually. The blue is forward, and the red is right, and the green is up, yeah? The y-axis. So there you go. So now we've got it sliding around. How long did that take? Barely any time at all. Coding is easy. The high-tech coding. We are dealing with a cube, and cubes only go in one of 4 directions, not even one of 5. One of 8 even. So really we don't want to be able to go left at the same time as going right. Let's get rid of these debug statements, we don't need these. During a roll, you shouldn't be able to roll somewhere else. We're going to have a private bool, which is true or false statement, and it's going to be like can start rolling, something like that, yeah? By default it's true. At the start of the script it's true. Once the game loads in. So then it's going to be if can start rolling and input.axes.horizontal button sensitivity blah blah blah, yeah? And we'll generalize this, by the way, we won't repeat the same way of doing this over and over again. Private means, for those who aren't accustomed with code, it means that no other script outside this one can look in and see and read the value of that directly, or set the value of it directly. It's important for not cluttering things up, for keeping... It's a very functional idea, is to keep everything contained within itself. Everything is self-sufficient. Anyway, so if you can start rolling, then, and this is the case, then you can roll, right? But for argument's sake, let's say that, just to demonstrate the kind of idea behind this, we say that, okay, if you've started rolling, then can start rolling is false, right? You can't roll anymore. And then we'll say, okay, you transform.translate. We're actually going to get rid of delta time just for this example. Just so it's obvious how much it's moved, right? And then we're going to immediately say, we're going to immediately just leave it there. Okay. So this is for the right axis, yeah? So as soon as I move right, then a roll animation will begin, and I won't be able to move anywhere else during that time. You notice there's nothing here which sets it back to being true. But for now, we're just going to demonstrate that. So I can still move around in the other ways, because I haven't rebound those. But if I try to move right, it moves me, and I can no longer move anywhere, yeah? So you can imagine this is whilst the roll animation is taking place. Then a super simple way we can do that is we can say, okay, how long does the roll take? Well, maybe the roll takes 1 second, yeah? So let's have a private IE numerator, which is like a coroutine. And we're going to call this roll, or rule, apparently. Roll. Does it need braces? No, it takes no arguments. There we go. Private IE numerator roll. It's going to be, we wait for a certain amount of seconds. Well, for how many seconds? Well, we could say 1 second here. Or, as is good practice, roll duration. Call it 1 second. Roll duration. We're going to wait for the duration of the roll. And then we can say, what was it, can start rolling, goes back to being true, right? So now let's get rid of time delta time for all these things. And we'll do the same thing. Actually, no, an easier way, rather than putting can start rolling in every single brace, let's just have a bigger if statement. If you can start rolling, then, hey, it did the auto, what? No, not allowed, wait. Why does it have to be so many tick boxes? Just let me decide where I want the brace, okay? Now what we could do, if we press both at the same time, then we could end up moving like that, but I'm not going to care too much about that right now. So, let's test this out. It should take 1 second. Alright, we move forward, and boosh, we zoom. Why do we zoom? Interesting question. It's because we never called the coroutine. If you can start rolling, if you do any of these things, then we start a coroutine. Oh, we need to set it to be false as well, obviously. But we can do that in the coroutine, actually. Start coroutine. Roll. With no arguments. There you go. Start coroutine, roll. Roll starts off by saying, can start rolling is false. We change the brace. This is going to become the first meme on this stream, isn't it? 1 second at a time. If I hold it down, it just moves, right? And you can imagine that doing a roll animation rather than just teleporting. Yeah? Alright, so now that we have that very simple implementation, let's actually make it roll. This is where things get a little bit more complicated. Ah, see, here's the difference between local and global coordinates. There's something good to talk about. So transform, the transform is the actual cube itself, right? You see the transform here? This is the transform. This is the cube. Transform.right is the cube's right, so it's this red axis here. So if the cube gets twisted, transform.right becomes over in this direction. Yeah? Whereas we don't want that. We're a cube rolling on a... Whoops, sorry microphone. We're a cube rolling on a grid, and so we want our cube to move according to the world coordinates. So rather than transform.right, we're going to use vector3.right, which is the unambiguous world coordinate axes. So there you go, we're going to do the same thing. Roll. Oh, I got... There we go. This is going to be vector3 dot negative right. What we want to do is to roll, is to move around an axis. There's a few ways we can do this. Numerator. This might not be the best way of doing it, but I'm interested to experiment. Okay, so what I'm aiming for is that every frame it updates this float until it exceeds the roll duration, I suppose. Yeah, and then we look at that as a proportion of the roll duration. So you do that within a loop, you could do. But you'd want that to be on a separate thread, otherwise it's going to block stuff. You could do it in an update. This is the nature of this stream, by the way. Occasionally you just have to sit and think for a bit. You don't put while loops in an update, that's silly. Coroutines start on a separate thread, don't they? So you're going to say while roll decimal is less than roll duration. Wait for the frame. I think this should work. And then roll decimal gets incremented. No, roll decimal gets incremented by the time it took to do that, which is time.delta time. There you go. So we should see it zip up to 1. Can start rolling goes back to being true. It was false initially. And we no longer need this. Get rid of wait can roll. And we don't need this. What does this do? Well, all this does is just increment the roll decimal, right? So just to check this is happening, within this loop, to make sure I'm not crashing the thread by using a while statement, let's log the roll decimal. Look down here at the console. And there you go, jump. It is spamming up. Counts all the way up to 5. While rolling, we want to be tilting about the front-facing edge, or the edge which is facing in whichever direction that we're actually looking in, you know? Okay, well, how do we find that edge? First of all, let's do a roll on the spot, whilst we're rolling. We know the proportion through the roll we want to be, right? The proportion we want to be is... it is the roll decimal over the roll duration. Right? Obviously. So that gives you a decimal between 0 and 1, which tells you how far through the roll you are. Then you can say, okay, well... ooh, excuse me. Well, I want to roll 90 degrees. Okay, so float angle. Angle from start. From the whatever angle you were originally in. Equals your roll decimal. Time over your roll duration, that's your proportion. Times by 90 degrees. At this frame, we want it to be this much. Next frame, it's going to be this much, and then you can just transform it, right? Okay, so the axes that we're rolling through is normal to the direction that we're wanting to roll in, right? If you think about, let's go back to GIMP, because we can discuss that pretty nicely. Okay, you're wanting to roll in this direction. Then the axes you want to roll in is this one. So say you're going forwards in Z, you're rolling it around X, right? Except you're not rolling it here. If we're rolling along the front edge of the cube, we're actually rolling something like... let's make it, say we want to roll this direction towards the screen. We want to roll along this axis here. Yeah? This one. And so I think Unity uses a right-hand rule for knowing which direction that's going to be, and we want to roll around like any point along this line, right? So presumably the center point. So there's two things we need to find. I held up X many fingers. Two things. We need to find the point at which we're going to be rolling in this axis, and we need to choose the axes which we're going to be rolling in. The location of our lovely cube, transform.position, minus, okay, now let's get the cube's kind of size. So float, I would call it radius, but radius is kind of for, it's width, isn't it? Let's call it half width. It's radius, but it's a cube, so does radius apply to cubes? Let me know, and then we'll change it to radius if so. Half the width is the, this is our shape, transform the size, it's the local scale, right? Dot X, it's a cube, it's the same in all angles, over 2. Okay? So, the point which we are looking at is the position, the center of the cube, down half a width. So that's vector 3 dot down times half width. and forward. Oh no, it's plus, sorry, plus vector 3 down, and plus vector 3 dot. No, in fact, it's just direction. We already have the direction. It's the direction we're rolling in times half the width. So we have our point. Point around. Next up, axes. Remember, back to GIMP. Got to be normal. They have to be normal to each other. This one, this is the direction we're going in. This is the axes we're rotating around. So there should be a vector 3. Probably some method we can call to get that. Perpendicular is vector 3 dot cross of those two. There you go. So we're gonna have vector 3 roll axes is vector 3 dot cross product of vector 3 dot up, because we know it's normal to the up direction, and direction. Okay, so now there might be an issue with direction of roll. We're gonna have to think about it in terms of whether it's positive or negative of the cross product. But for now, we're just gonna try and see. Roll axes. By float angle from start, right? There we go. Now, something might go wrong, but this is enough for it to move anyway. We're transforming it in this loop here. Let's give it a shot, shall we? Who wants to give it a go? Kinda nervous. That was a whole chunk of code without much testing. Ha 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 ha! Yes. It's always the best thing, right? Let's get a slow-mo reshot of that. You ready? So it's rolling off into infinity, yeah? Let's diagnose the problem. Oh, in fact, we don't need to create this inside the loop every time, do we? Oh! That's the issue. That's the issue. Okay, look at this. As we roll around our point, our cube moves slightly. Yeah? Which means this changes. It's got a bit of a feedback loop going on. Move the roll point outside of the while loop. It's from the origin, the original position, right? We also don't need to change, we don't need to instantiate this every iteration of the while loop. The size of the cube is not going to change, presumably. The axes over which we roll is not going to change. We don't need this much stuff in our while loop. Anything which isn't changing has no business being in there. All we want is to increment our time, change our angle, and do the actual roll. Let's try it now. This is why coding with objects is far. It's just funny. Okay, what's going wrong now? Okay, so we're not spinning off to oblivion, right? But we're not stopping either. I think it's probably because of our angle. The angles we're going through is far too many. Probably because it's... Is it in Euler or is it in quaternion angle? Float angle from start. We're not rotating it by a greater value every loop. We're, unless we are. Maybe I'm being too arrogant. Let's have a look. Oh! Oh! Nice work, guys. Nice work. This is total angle. I'm trying to do total. I'm not trying to rotate it. I'm trying to adjust its rotation to an absolute value, not to a difference. You'd find a difference pretty easily. Old angle from start. Old angle. New angle. Rotate through equals the new angle minus the old angle, and then the old angle becomes equal to the new angle. Oh, it's because of new angle. No, it needs to be rotate through. That's why. That's what I'm doing. There you go, rotate through. It was just the wrong one. And it better be the wrong one, otherwise, you know. There you go. Thank you very much. Applause, applause. And look, we can now roll in any direction we like because of the way I set the positioning. And 1 second is very slow. Let's make this 0.25, maybe a quarter of a second, right? Streaming is the ultimate rubber ducky. That's true. Hey, look at that. Okay, now you see what's happening now is that we're accruing errors over time, right? We're just sinking slowly into deeper and deeper into the floor. Of course programming is a thing you can be okay at. No, that's very wrong feeling, Kish Brown. No, there are definitely levels of skill of programming. Some people are worse than others, some people are better than others. Absolutely. Don't think that you are either not good or you're good. Because otherwise, anyone who's not good is going to consign themselves to their fate, you know? There are people who have aptitudes, natural aptitude for programming, which helps. But work and dedication and enjoyment more than anything are far more prevalent factors to how good someone is and how much better they can improve than natural aptitude is. Absolutely. Rolling Cube Simulator. Pre-order now, donations at streamlabs.com/hotgaming. Hook me up, Patreon dollar, bro. Let's get Cube Simulator made. Let's get it kickstarted. But you get the point. This is quite an in-depth tutorial on how to do rolling. We're gonna save the original rotation, quaternion rotation equals transform.rotation. You just multiply quaternions. That's how you transform them. So rotation times by our roll axes times by 90 degrees, isn't it? This seems a bit convoluted. I'm sure there's much better ways of doing this. So we can set the end rotation to be correct, and then we know the start position, we know the end position. So vector 3 end position is just going to be the transform.position plus direction. There you go. So then once it finishes its stuff, then we can just say transform.position equals end position and transform.rotation equals end rotation. And you can start rolling again. There you go. See? We got rid of the error. There's no like accumulating kind of slight difference over time, because every time we get to the end of a rotation, we snap to where we should be. So this will roll perfectly within the grid lines, and should really roll perfectly. So there you go, a rolling cube. My god, the first component of the game Owl's Breeze, which is what we're heading for. I will be live streaming relatively regularly, probably on the order of once a week or so, we will see. And the idea is that we're going to build up a game very slowly, and just generally chill out, do some cool coding. If you want, you can support me on patreon.com/hocgaming, just so I can justify making these a bit more often, and also the other kind of bigger videos that I'll be doing, which involve a lot of drawing and whatnot. And I might be able to show you some kind of sneak peeks of upcoming videos, stuff like that. Otherwise, if you don't want to support on Patreon, you can always donate. Streamlabs.com/hocgaming does the same thing, just a bit of instantaneous cash and no obligation for the future. And otherwise, just enjoy the videos. Thanks very much for watching, and I'll see you next time.